thanks very much for that introduction. Just to say a little bit about myself for anyone who doesn't know, I graduated from St Andrews in the late 1970s. I did a master's degree at Glasgow University just a few years ago, and I've been living in Mull since October 1998. The 2nd of October is our wedding anniversary, so this is where I live. And I spend quite a bit of time, as anyone who follows me will know, looking at the geology, trying to promote it on social media. I do walks and talks and all sorts of good stuff whenever I can. So if it's Mull and it's geology, then I'm interested. So one of the things that's really quite fascinating about these islands is tonight's subject, columnar basalt. And that's what I'm going to talk about tonight. So we'll just get going through the slides. There's lots of pretty pictures. There's quite a few slides actually. So hopefully we can fit it all into the hour. And if you've got any questions, then ask them at the end. So this is the sort of stuff that we're going to be talking about tonight. These pictures, now you'll see these pictures later. The top left is a place called Archgeric near Alva Ferry. That one on the top right is Ambuchel, the herdsman, the little island off Staffa. That strange looking thing in the middle left picture is a radial columnar basalt formation near the fossil tree. On the right there in the middle is Alva, the famous basalt columns at Alva. Down the bottom, we've got the world famous Fingal's Cave on the island of Staffa. And that one at the bottom right, that is the Karlis Arches, which aren't actually that close to Causeway. They're a bit of a walk from it. But yeah, that's the Karlis Arches. So tonight's topics, a little introduction, which I've just done. I'm going to look at what resources are available if you're interested in taking this sort of thing further. Ask the question, what is basalt anyway? What is it? We'll have a look at that. We'll look at what columnar basalt actually is and have a look at two famous examples of it, which we'll look at in a bit of detail. And then we'll talk about the formation of columns and a thing called the Staffa lava formation. Now, the Staffa lava formation is the main body of columnar basalt that you find throughout Mull, Alva, and Staffa. It's named after Staffa. So we'll look at it's well studied. It's been well researched. So I'll be talking about that in a little bit. And we'll be looking at what's called the paleo landscape. The paleo landscape is effectively the landscape that was there that the lavas were poured out onto, the pre-existing landscape that was covered in lava. And we'll look at some Mull localities plus lots of pictures of them. And we'll have a look at other places that have got columnar basalt, not just Mull. And I'll also have a look at other columnar rocks, because there are other rocks that take on a columnar appearance. So a quick look at the various books and things that you've got. In the top left there, we've got the Paleogene Volcanic Districts. This is it's not that old, this book by Henry Emilius and Brian Bell. Very, very good. It doesn't just cover Mull, it covers Skye, Ardnamurchan, Rum, the Small Isles, this Arran, the whole area. Very, very good, very thorough, with beautiful illustrations in it. The next one along that you can see is one of the Landscapes in Stone series by Alan McCurdy, and the title is self-explanatory, Mull, Iona and Ardnamurchan, and it gives a basic intro to the geology. That one in the middle at the top is the Tertiary Igneous Geology of the Isle of Mull. This was produced by the Geologists Association in the 1960s, and it's still really the only excursion guide to Mull. So there's a big gap there, needs filling. To the right of that, we've got Mull in the Making. Now, this is one that stood the test of time, written by Ros Jones. It's a really good account of Mull's geology through the ages. Over on the right-hand side there, you've got three maps, the Ross of Mull, Staffa, and Eastern Mull. You can't really look at the geology without having a good look at the maps as well. In the middle of the bottom there, you've got Mull and Iona, a landscape fashioned by geology. And that's the book that SNH published before the Landscapes in Stone series. That's still available secondhand in various places, and it's very good illustrations. And in the bottom left there, we've got two memoirs of the Geological Survey. The memoirs of the survey are the accounts that were put together by the survey officers once they'd finished all their surveying in the early part of the 20th century. And these are really, really thorough volumes. These are ones for the really keen people that really want to know more about the geology. It's seriously scholarly works. and well worth reading if you are keen and interested. So there's some online resources that are worth mentioning. The British Geological Survey maps are all available to look at online on the BGS website. The memoirs of the survey, those memoirs that I showed in that previous slide, you can read them online as well. Now you can't really download them. You can't, they're not like PDF files, but they can be read online. Nature Scott, which was previously SNH, has the landscape fashioned by geology booklets available as PDFs to download. They don't cost anything. So you can get there's landscape fashioned by geology booklets for the whole of Scotland, and they're well worth downloading, having a look at if you can't actually get a hold of the printed copy. Google is also your friend if you're looking for stuff. And in particular, Google Scholar. Now, I don't know if a lot of people don't know about this, but scholar.google.co.uk allows you to hunt for published papers, peer-reviewed research. And if you just go to scholar.google.co.uk and if you put in, say, columnar basalt, like I did here, you'll get a whole list of, that's 28,000 records that refer to columnar basalt, and you can sort them by time and author and all sorts of stuff. So yeah, there's a lot of resources out there. Of course, a lot of the papers that are online, you have to have an academic login to be able to get access to them. They're not always that freely available, but you can usually get the abstracts, and sometimes that's all you need to get a little bit more information about something. So of the published papers, there are 3 that are of quite considerable interest to what I'm doing tonight. This one about multi-tiered columnar basalt flows by Paul Lyle actually gives a lot of good information about the formation of columns. It's really, really good. It's actually quite easy to follow. That was published in 2000. There's one called, this one here, this is a massive paper, this thing, by Brian Bell and Ian Williamson. Brian Bell was my supervisor at Glasgow. The Staffa lava formation, and it describes it and how it developed, and it's just an amazing piece of work with great illustrations in it. That was 2012 that came out. And there's another one, fossil trees, tree molds and tree casts in the lava field. This again is by Bell and Williamson just a couple of years ago. And this is really interesting about the various fossil trees and things that have been found in the lava field. And I'll be touching on this later. So the first question is basalt. What is it? Well, the first thing is it's an igneous, it's a volcanic rock. And if you've been looking at the news over the past week or so, you'll have seen basalt in action pouring out of the volcano in La Palma. That is basalt that's pouring out there. Also, if you're looking at the volcanoes in Iceland and also Hawaii, it's basalt lava that's pouring out. It's the commonest rock type in the Earth's crust. Most of the ocean floor is made of basalt. Very, very common. It tends to be fine-grained, can be slightly coarser grained, but generally it's a fine-grained rock. It's fine-grained because it's cooled down quite quickly. Igneous rocks that cool down quickly will develop a fine grain. If they cool down slowly, they'll develop a coarser grain. It can be dark grey to black in colour. There's all sorts of variations between it. Sometimes you get a bit lighter, but generally it's dark grey to black. In terms of its chemistry, it's defined as being 45 to 53% silica. That's what a basic igneous rock is. So it's, you don't have to worry too much about the technicalities of this, but that's the official definition. It's rich in iron and magnesium. That's quite important because there's quite a bit of iron in it. It's quite a heavy rock. It feels quite dense. It tends to be more fluid and less viscous than silica-rich igneous rocks. And by silica-rich igneous rocks, I mean granitic type rocks. So basalt tends to run quite a distance, and it's not thick and sticky. Its eruption temperature is between 1100 and 1200 degrees centigrade, so it's pretty hot stuff. And that's one of the reasons that it's less viscous. It's so hot, it's very runny. And it tends to form thin, extensive flows. Basalt lava flows tend to be, not particularly thick, but they'll go for quite a distance. You also find it on the Moon and Mars. I'll be talking about Mars later. So it's it's not just found on Earth, it's found in the other parts of the solar system as well. So here's some pictures of basalt in action. There's an image of basalt in Hawaii, just crawling about, very hot, starting to solidify there. And that is a fissure-fed eruption. That's where it comes out a crack in the ground. That's very common. And that scenario that you see there, that would have been very common in Mull 60 odd million years ago, because most of the basalt that was erupted on Mull is reckoned to have come from fissure-fed eruptions. There's a quick wee diagram here to show you some of the volcanic features. Some of this is quite important. Deep underground, you've got these great bodies of igneous rock. And if it makes its way to the surface, it's called magma when it's underground. When it makes its way to the surface, it comes out as lava. So you've got a volcano there with lava coming out. Also what's called pyroclastic deposits, which are things like volcanic ash. You'll see there are sort of vertical features going up the way called dikes. Now there's lots of dikes in Mull. They can stand up like a wall of rock. The dikes are where the magma has pushed its way across the strata. You'll also see things called sills. Sills are where the magma has pushed its way in between the strata. So they tend to be underground. And if we ever see sills, it's because they've been eroded away. But dikes can make them way through all the way to the surface. And there's also a thing there called a laccolith. Some good words in geology, some great expressions. And you can see how the laccolith has pushed the strata above it up. It's caused a bulging upwards. On the right there, it describes those rocks at the top as extrusive volcanic rocks. In other words, these are ones that have come out at the surface. And the ones underneath are what are called intrusive or plutonic igneous rocks. These are ones that solidify underground. The other thing is on the left-hand side, it talks about the cooling rate. So if they cool slowly, you get a big grain size. If it cools quickly, you get a finer grain size. And there's a sort of stuff in the middle that can be sort of medium grained. So that is a basic volcanic sort of province. You know, that's a stylized one, what it might look like. And you know, throughout the Hebrides and things, you'll find stuff like this. Oh, that might not look as neat as these diagrams. So this is basalt on the top left there, that dark, fine-grained stuff. On the right, you've got the medium-grained equivalent called dolerite. And at the bottom, you've got gabbro. Now, these are all chemically very, very similar. But the difference is in the grain size and the cooling rate. The basalt at the top has probably come out of a volcano and cooled quickly, and it's fine-grained. The dolerite that you see in the middle there is probably solidified on a dike or something like that and cooled a little bit more slowly. And the gabbro is what you get deep underground, cools down very slowly. And all the gabbro that we see today is exposed by erosion. And the famous gabbro hills are the cooling of Skye. But you've got gabbro in Mull as well. Ben Bui is a famous gabbro location. But these are basically all variations on basalt. And the appearance can vary quite a lot. That thing in the top left is called vesicular basalt. It's full of holes. These are gas bubbles. If there's a lot of dissolved gas in the rock, when it comes up, it can form bubbles. Any of you that are familiar with the sort of volcanic rocks, well, anywhere in Mull, you've probably seen these red lines in the rock, these red areas. Those are effectively the top of a lava flow. That's a lava flow that's been eroded away, and it's broken down to form this red material called a red bowl. So that's the top of a lava flow that you're seeing there. And they're quite common. In the bottom left, we've got a big chunk of basalt, which has been broken. So you can see the fresh surface, which is grey. It looks quite light grey, that one. And you've also got the weathered surface, where it's been broken down by weathering, by water and erosion and what have you. And you'll see that it's got a brown rusty colour. And that's because of the iron-rich minerals breaking down that come out of it. And that thing on the bottom right is an example of what's called amygdaloidal basalt. The one on the top left is basalt full of holes because of gas. If at a later stage in the process, those voids get filled with crystals, which can happen quite a lot, you end up with this thing with these little crystal voids. And if the crystal voids are big, they get called geodes, but most of the ones you'll find in Mull are quite small like that. And that one in the middle looks a bit like some sort of human figure. So these are amygdales, these are called, these little cavities, very common. So there's different varieties of basalt. This is where it gets a wee bit technical, but I'm not going to dwell on this too much. they're basically divided on the basis of their chemistry. You've got a plain vanilla basalt, and there's other varieties. And the names of some of these are quite interesting. There's one called Hawaiite, named after Hawaii, obviously. And there's a more local one called Mugurite, named after Mugurian sky. There's one called Benmorite, which is named after Benmore in Mull, where it was first described. And there's many others. There's a lot of other different varieties. They are shown in what's called a TAS diagram, total alkali against silica. And by measuring the alkalis against silica, they subdivide the basalts, and you get a diagram like this. Now, it's just for reference. I'm not going to go into this in any detail at all, but these are all variations on basalt. And down the bottom there, there's some even finer subdivisions, and there's Mugurite and Benmorite in there, and various others, Hawaiite. But don't worry too much about this. It just shows you how they're actually divided up on the basis of their geochemistry. Now, this lot all comes together because there is some plain vanilla basalt forming columns at Ulva Ferry, okay? So quite nice little columns there. These are probably the easiest columns to see in Mull because you can almost drive right up to them. So you've got that on the ferry, you get on the boat and you go across to Ulva. And you're on Ulva looking over to Benmore. So you're standing on Mugurite. That rock in the foreground is called Mugurite. And if you look at the top of Benmore, you've got the rock called Benmorite up there. So all that stuff that I showed in that previous slide also hangs together here. Okay, there's also some other interesting things. This appeared on the BBC website a few years ago called the Cosmic Coincidence on the Road to Glenelg. There's a place defined as Glenelg on the planet Mars. And when the rover that was sent there did an analysis of the rocks to get there, it discovered that the rock is actually Mugurite. So you've got this rock called Mugurite on the way to a place called Glenelg on Mars. Now, Glenelg in Scotland is only a short distance from Skye, where Mugurite was first described. So that's why they're referring to this as a cosmic coincidence. It's quite amusing. And that's the BBC link for the news story. So let's have a look at some geological maps before we go any further. How is basalt actually shown on the maps? I'll have a look at the BGS map first of all, and then the simplified one in the SNH book, and then the Geology of Britain viewer, which the BGS has on its website. This is all available online. And what is also available online, if you go to the National Library of Scotland website, is you can get the old geological maps, the ones that were originally published, and they're quite interesting to look at and compare with the newer ones. Okay, there's the classic Eastern Mull geological map, the one I always refer to, and people are probably sick of me referring to it as an explosion in a paint factory. It's quite impressive, especially in the middle. I'm not going to dwell on this too much, but all that pink stuff that you see sort of around the edges, that's basalt lava. This is the map in the SNH book, Landscape Fashioned by Geology, where they've changed the basalt to a green color. I think this map actually explains it a little bit better. It shows it better because there's not so much detail. But as you can see, most of Mull and that good chunk of Morvern is made of basalt. And these islands off the west, Ulva and Staffa, what have you, Treshnish Isles, they're basalt as well. And this is the Geology of Britain viewer. Now, this isn't interactive here, it's just a snapshot of it. But you can actually go onto this and zoom right into it and do a right click and find out what the geology is in that particular location. So you can go to your hometown and look at the geology. It's a great little resource. It's basically the geological map digitized into an interactive web feature. It's very, very good. So columnar basalt, this is what we're going to be properly looking at. It forms polygonal columns, but under specific circumstances. Not all basalt forms columns. 6 sides are common, but you also get 5 and 7. I think you get 4 and 8 as well, but that's pretty rare. They're not always regular hexagons either. They can be sort of misshapen hexagons. There's 2 features referred to as colonnade and entablature, and I'll look at this later. Colonnade refers to nice, regular, straight columns. Entablature refers to the really bent, twisted ones that you get on top of colonnade, which is well seen in Staffa. When you go to Staffa, the colonnade and entablature feature is really, really pronounced. Basalt lava is the commonest example of a rock that forms columns. I mean, you get other rocks that will do it as well, but it's the lava, is the basalt lava is the commonest thing. You'll get columns and dikes and sills as well. We will see some of these later. And sometimes if you've got a sill and it's not terribly well exposed, it can be quite hard to say, is that definitely a sill or is that a lava flow? It's not necessarily obvious. Other igneous rocks can display columns too. Now I'll show some of these later. And even sandstone, this is extremely rare, but you get columnar sandstone. It's found in Isle of Bute, and I'll show you that later. So two famous locations. First one is Staffa. The second one is the Giant's Causeway. I'm just going to look at these in a wee bit of detail. And we'll look at the formation of columns with particular reference to these. So there is Staffa. Now at the top, you've got the twisted columns, the stuff that's all over the place that gets referred to as entablature. Further down, you've got the main columns, the really impressive stuff that looks very regular. That's the colonnade. And you can see how some of it's eroded away and disappeared. You've got Fingal's Cave there on the approaching the right-hand side, famous Fingal's Cave. And on the left-hand side, it's sort of sea level and below the main columns, you'll find there's a different rocks, a fine-grained ash. That's a volcanic ash. And it's very often the case that when you get volcanic activity, the ash is what appears first before the lava does. And the reason for that is when volcanic activity starts, it can be quite explosive. There can be quite a lot of gas involved in it. And that breaks the stuff down and produces this fine-grained ash, which comes out first. Once the pressure has gone down a bit, you get runny lava coming out. So very often at the base of the sequence, you'll find ash like this here. The other thing you'll notice is that it doesn't look like it's sitting level. It looks like it's tilted. And the lavas in Staffa are definitely tilted. So I'll look at that later. And here's the famous Giant's Causeway in Northern Ireland. Beautiful hexagons there. It's more extensive than Staffa. It's different because it's on the coast rather than an island. It's got a different appearance, a different feel to it. Still pretty impressive. That's the Giant's Causeway on a good day. Nice regular columns that you're seeing there. So the formation of the columns, how does this all come about? Well, the best paper, and I mentioned this earlier, is this one by Paul Lyle, University of Ulster. He obviously had great material to work on right on his doorstep with the Giant's Causeway. So he looked at the eruption, as it says there, the eruption environment of multi-tiered columnar basalt lava flows. And the study includes the Giant's Causeway, Staffa, Mull, the Columbia River basalts in America. And it's a really good explanation of how columns form. And there's a few features that are quite important to bear in mind when you're looking at this sort of thing. The first thing is that these cracks that you get, these vertical lines, they're called joints and are caused by contraction cooling. This stuff comes out the ground pretty hot, as you saw earlier, about 1100, 1200 degrees centigrade, and it starts to cool down. And as it cools, it shrinks and contracts, and you get joints appearing, as they're called. All igneous rocks will do this. The joints can be vertical to give the columns. That's what we see. That's what we see in in Staffa and Giant's Causeway. They can also be different orientations as well. But we're talking about the vertical ones here just now. The important thing is that the joints, the columns, if you like, develop at right angles to the cooling surface. Now this applies to dikes and sills as well. If the stuff is cooling vertically from a cold surface, then you'll get vertical joints, you'll get vertical columns. With dikes, where it's been injected into a crack in the Earth's crust, the columns tend to go across the way. And I've got pictures of that I'll show you in a wee while. There's, with sills, it depends on the angle of a sill, but I mean, most sills are sort of horizontal. And again, you can get vertical columns forming as the sill cools down. Of course, the sill will be cooling down underground rather than at the surface. So it's probably got a coarser grain size as well. You also get horizontal lines, cracks, joints in the columns. They're called chisel joints. And these are really noticeable in places like Staffa and also near the fossil tree in Mull. It makes the columns look like a big pile of nuts. I don't mean nuts that you eat. Mechanical nuts, metal nuts. The hexagonal things. It looks like they're piled on top of one another. But this is one of the important things. The presence of water is important to get the columns forming. There has to be water available for this to happen. Because if you'll see basalt lava flows in other places where there's no columns at all. It's just a big massive pile of hardened basalt. So the columns require water. That's what this paper in that I showed you there earlier talks about in quite a bit of detail. The other thing is that a lot of the columnar basalt has been ponded in river systems. So it's not just flowed out onto a flat land surface. It's been enclosed in river valleys. The colonnade that we saw earlier, the straight columns, they form the columns from the bottom up. And the ones called entablature, according to this paper anyway, form from the top down. So there's Staffa again. You've got the colonnade in the middle, you've got the ash layer at the bottom, and you've got the entablature above it. So the stuff called a colonnade would have cooled from the bottom upwards, and the entablature would have cooled from the top downwards. And I said, notice the dip of the lavas. It's because they've been displaced after they were solidified. They didn't flow out at that angle. They would have been horizontal and then tilted by later earth movements. So the Staffa lava formation gives us a little bit more information about this. The Staffa lava formation is the lowest lava formation in Mull and Ulva and Staffa and other places. And it's famous for its columns. The columns are the thing that really stand out about the Staffa lava formation. It's extensively described in that Williamson and Bell paper that I showed earlier. This one. This goes into immense detail about the Staffa lava formation. And how does it fit in with Mull's igneous activity? Well, it's extremely complex. You just need to look at the map to think, well, whatever's been going on here is pretty detailed. It all happened over about a 3 million year period, about 60 million years ago. And at the base, there's what's called a basal mudstone. It's just a very fine-grained, muddy rock. We don't see what's called the KT or the KPG boundary. This is the famous extinction boundary when the dinosaurs died out, as well as a lot of other things. That's been eroded away. So we don't actually see that. We don't see the boundary between the Cretaceous and the Tertiary, or the Cretaceous and the Paleogene, as it's known now. But we do see, lavas lying on top of these older rocks. So the first phase, the first thing that happened was the eruption of lavas, and the Staffa lava formation was the first of these. You get dikes as well being pushed through the thing. The whole area was very active at the time. There would be a lot of earthquakes and fissure eruptions happening. After the lavas were erupted, we got what's called the central complex. Now that's that really complicated looking bit on the map. That came after, and that's why the lavas in places like Staffa appear to be tilted. It's the effect of the central intrusive complex pushing the ground up and causing it to tilt. If we see the next slide, this shows you the age of the various igneous places up the west coast and what happened when. So the pink stuff that you see there for Mull on the left-hand side is the intrusion of the lavas. That's lavas being intruded, and lavas being extruded rather. And then above that, you've got some green stripes. That represents the central intrusive complex. And there's a little bit of gap in the middle there that they've identified when not much was happening. But yeah, so the intrusive stuff, the complicated stuff came later and disrupted the lavas, which came earlier. That black line, that single black line running through represents dikes, which occurred right from the beginning right to the end. And I've also got similar diagrams for Ardnamurchan and Skye. And you can see that the time scales, they all sort of started about the same time, and Skye it finished a little bit later. But yeah, that's I mean, this diagram's from the MLS and Bell book, and there's actually other places as well given the same treatment. So what actually is it? As I said, it's the lowest member of the Mull lavas. It's quite restricted in its distribution. You don't get it everywhere. It tends to be quite localized. And the columnar basalt is very common within it. Not all the time, but it's one of the very distinctive features of it. You've also got associated sediments between the flows. Now, the reason for the sediments is because you would have got a basalt lava flow coming out, and then there was a period when there wasn't much happening, and this thing would have got worn down, eroded, weathered away, and you get sediments forming, and then you get the next layer of basalt on top of it. So there were periods between the lava flows when there was what they call quiescence, when there wasn't much happening except a bit of erosion. With the later lava flows, the main pile of lava on Mull, this isn't so common. Because of this, you get plant remains, you get trees, leaves. There's the famous leaf bed at Artun, where fossil leaves were found. And there's also McCulloch's tree, the famous McCulloch's tree in Ardmeanach, which is quite a spectacle. You'll see it later. I've got pictures of it. Staffa is the type locality for the Staffa lava formation. Obviously, that's where it's most impressive. The other thing is the basalt lava of the Staffa lava formation is highly contaminated, apparently. So as it's come up through the Earth's crust, it's eaten quite a lot of material, crustal material has got in about it and mixed with it and contaminated it. So it's just a feature of it. For those that have been examining the geochemistry have found this out. And I think I read somewhere it's the most contaminated lava in the whole British Paleogene Igneous province. So it's just a thing about it. And as I mentioned earlier, because of the sediments, there's long periods between the flows. There have been long periods of time when there wasn't much happening. And then you've had another burst of activity. But the Mull Plateau lavas, the ones that are up above the Staffa lava formation, it was much more continuous extrusion of lava. So where is it found? Well, it's mainly in southwest Mull. Ulva and Staffa are cracking locations. There's also some stuff that looks very like it near Tobermory. If we look at the next map, we'll see this. Then we've got pictures of each location. And also there's some notable areas where it's not found, like Greeben. You don't get it at Greeben. I mean, at Greeben, you've got the sedimentary, the Mesozoic rocks lying on the shore, and then you've got the lavas above it, but there's no columnar basalt there. It tends to be low down near the coast, not up high. So you tend, I mean, although having said that, the greatest extent, the greatest vertical extent of the Staffa lava formation is found at Malcolm's Point. That's where the Karlis Arches are, and it forms the whole cliff there. But for the most part, it's down low near the coast. The higher hills in Mull are mainly of what's called the plateau basalts. These are the later ones, which are slightly different. So we're going to have a wee word about what's called the paleo landscape. Now, the paleo landscape is the land, the terrain that these lavas were erupted onto. So what does this word actually mean? Well, I've just described it. It's the pre-existing landscape before the volcanic activity. So this was at the end of the Mesozoic, at the end of the Cretaceous, before all this eruptive stuff started to happen. So you've got these older Mesozoic rocks underneath, which are either Triassic, Jurassic, or Cretaceous, depending on the age. This landscape was a landscape of strong relief. So there were hills or valleys. It was quite dissected. It was cut by rivers. It wasn't just a nice flat, planar surface. It was well broken up by, surface processes. Rivers, lakes, valleys, all this would have been present. And we can tell this by the way that the Staffa lava formation has formed over the top of this. So it wasn't a flat plain. The valleys caused ponding of the lava. A lot of this lava would have been ponded. It would have been held in these river valleys. And as a consequence of that, you've actually got some quite thick lava flows. Now, I mentioned earlier that the basalt lava tends to form thin, runny flows. But if you look at that stuff at Staffa, that's actually quite a big, thick pile of lava there. And that's because it was held in a valley type system, causing ponding. And that's why you've got a bigger volume of it building up. The presence of water caused the columns. That's a critical factor. So a valley with a river running through it, probably quite a bit of rainfall. And then you got this lava pouring into it and the columns forming. This is from the Williamson Bell paper. And this paper is absolutely full of cartoons like this, showing what the pre-existing landscape would have looked like. And up there's Ulva at the top, a floodplain lake with algae and fern marsh. And you've also got this great big valley system here with Staffa at one end and Malcolm's Point where the Karlis Arches are at the other. And you've also got hills, you see over on the right-hand side there. Also points out where McCulloch's tree is. So that's the type of landscape that would have been. It would have been valleys with this stuff filling them up. You'll notice that hill on the right-hand side there. That indicates some of the higher land, some of the more elevated land where the lava would have just run off effectively. And that's why at places like Greben, you don't see the Staffa lava formation, because that would have been slightly elevated land at that time. So there wasn't a place for the lava to pond, to gather. It would have basically run off. So you didn't get the build-up that you have in these valleys. So the Williamson Bell paper is absolutely full of illustrations like this, and they're absolutely fascinating, because what they've done is by looking at the lavas, by looking at the sedimentary layers in between, and working out what kind of things would have been growing there and what kind of environment it would have been. So they've been able to build up a picture of what the paleo landscape would have been like at the time, both before the lavas poured out and during the periods, the quiescence periods, when in between lava flows, when there were plants and things growing, plants and trees and things. So it's really quite fascinating. It's a complex paper. There's a lot in it, but it's really, really interesting. This is, I mentioned the plateau lavas. That's what you see in places like Ardmernach. This is from the SNH booklet. So we're looking across from about Benesson area, Artun. We're looking over to Ardmernach, and that's the part of Ardmernach that gets called Berg. Berg is where the fossil tree is over on the left-hand side around the corner. So you've got the plateau basalts forming these distinctive terraces, and the Staffa lava formation is close to the shore on the left-hand side. So most of what you see there is the plateau basalts, and that's what gives these terraced, and the flows are much thinner and very level, as you can see. So let's have a look at some examples from Mull and the islands nearby. We've got Staffa, Ulva, look at Ulva from the sea, Ulva Ferry, Arsgerich, Karsig Arches, east of Karsig, some nice stuff. There's a place called Glachvor near north of Tobermory. There's some good wee columns there. There's the wilderness of Ardmernach, that's where the fossil tree is. And there's Artun, where the famous leaf beds are. So I've got pretty pictures for all these places. All these have got nice pictures to illustrate what columnar basalt can look like, how exciting it can be. And yeah, I mean, it's exciting stuff. It makes geologists jump up and down with excitement. Well, it does me anyway. So, and we'll go east of Skur as well. The bit near Skur, there's some lovely basalts there. Some interesting stuff in it. And also have a look at the Laggan Peninsula. Now, I was on a boat trip around the Laggan Peninsula of southeast Mull, and that's some of the most remote territory in Mull. Just a couple of weeks ago with a guy called John Mon. And we had a great look at the rocks close up. And there appears to be some columnar basalt there. Now, I've never seen it referred to anywhere else. I can't think of anywhere it's been mentioned, but it definitely looks like columns there as well. So I'll show you pictures of that taken from the boat. Okay, this is Mull. This is the map from Bing, satellite image, very, very clear, showing you the various places. So up at the top there, just north of Tobermory, you've got Bloody Bay and Glachvor. There's Ulva Ferry. The place I called Arsgerich is just round from Ulva Ferry. There's Staffa, the famous Staffa out on the sea there. You've got the wilderness, that middle peninsula that sticks out in Mull is called Armeanach, and the wilderness is the far left-hand side of it. Just across from that is our Tun, where the famous leaf beds are. And on the south side of the Ross of Mull, you've got Causeway, you've got the Karlis Arches, and Laggan that I mentioned is down there in the southeast. Now, as you can see, the vast majority of these columnar basalts and what have you are in the southwest of the island. That's where most of this activity seemed to be taking place. And probably because the rest of the island, the rest of Mull, was higher ground at the time. So the lava ponded and flowed into these areas in the southwest. So Staffa, first of all, you never tire of pictures of Staffa. There's the classic view. There's a cave in the ash layer. I suppose the ash is probably softer than the main body of rock, so it erodes out easier. Fingal's cave itself is over there on the left or right hand side. I've often wondered about Fingal's cave, why there actually is a cave in there. If you look at the roof of Fingal's cave in the bit they call the entablature, the columns are all over the place. You'll see there's what looks like a crack running through it. So I think that's a fault. I think there's been a bit of movement along that. And that's allowed the rock's been crushed, it's weakened, and the sea has just exploited it and broken through. And it faces southwest anyway, so it's going to be vulnerable to that sort of thing. And that's the boat going into Fingal's cave. And you can see that crack I was talking about up in the roof of the thing. There's a definite feature of some sort there running through the entablature. So yeah, again, there's people there, so you can get an idea of the scale of the thing. It's an amazing location. There's another view of Staffa. I say you can never have too many views of it. And in the distance there, you can see the island called Bachmoor, or the Dutchman's Cap, that flat sombrero-like looking thing. And again, you can see the ash layer underneath the lava very, very clearly there. Just off the east of Staffa is Ambuchail, the herdsman. And this little island separated by a little deep channel from Staffa itself. The basalt columns there are all over the place. The angle of the columns is at right angles to the cooling surface. So probably what happened there was a bit of a river, a bit of a river valley, a bit of a curved surface that it was cooling against, and that's why the columns look like that. I mean, some of the columns in Staffa are superbly curved, which we'll see in a second. But yeah, the Ambuchail is a great little island. Always wanted to visit it. This is towards the north of Staffa. Beautifully clear water, as you can see. Some nice columns there. But as you get further north, the columns tend to die out a bit. They're not quite so pronounced. And this is the famous clamshell cave. This is just at the landing stage for Staffa. You can see the steps going up to the high point there. And I think there's people on there. But yeah, they're beautifully curved. And again, that reflects the shape of the landscape that cooled against. There we are again. And you can see people coming down there. Gives you a sense of the scale of the thing. That's Ambuchail on the left. And the clamshell cave is well named because of the appearance and the shape of it. It's an incredibly difficult thing to photograph because it's, you're sort of facing south. And invariably when you're out visiting Staffa on one of the boats, it's getting on towards the middle of the day, so the sun is always in the wrong position. It'd be, you need to go there sometime and stay out on it overnight and midsummer and get a good picture of the sun in the right position. But yeah, clamshell cave, an impressive looking thing. And a little bit north of the clamshell cave, again, you've got these curved columns, quite distinctive. And as a final view, looking down onto the ash layer, the tide must have been quite far out there. At the bottom, at the base, and the columns, the colonnade, and then entablature above it. So that was Staffa. Now, Staffa's the best place to see the columns. There's no doubt about that. It's been said by a few people that Ulva is the second best place to see them. So let's have a look at some Ulva pictures. This is the Ulva basalt columns on the south side of Ulva. Really nice. These are great, these things. And they're actually easier to get to than Staffa. You've only got a very short boat trip, and it's just it's like a 40-minute walk to get to these. That's two friends of mine sitting beside having lunch, sitting beside the columns. Gives you a sense of scale. That was a beautiful day. That was May this year. And here again, just around the corner from there, you can see the columns, and there's some little sort of little gullies dug into it here for some reason. Again, it might be faulting that's caused crushing, a bit of erosion, and the rocks have just collapsed. But the thing you notice about a lot of these columns is there's a lot of collapsed ones. You know, a lot of it doesn't look terribly substantial. And again, just for, you've got people there for scale, and you can see the Ulva columns, and they stretch away into the distance to the west there. This is the classic view of the columns in Ulva, taken from the cliff top, looking down. That's Greben in the background that you see. And there's Benmore, the point of Benmore, and just the highest point there. And I mentioned the intersedimentary layers. Between the lava flows, you've got these layers of sediment. This is some sort of conglomerate with a sandy matrix in Ulva. And you can see a lot of collapsed blocks as well round about here. That's just round the corner from there. So that's I mean, what's happening is the cliff is being eroded. It's gradually being eroded back by the sea. And the cliff line is going backwards inland. So you've got these spurs of rock that stick out, and great piles of the stuff lying there. Ulva from the sea looks quite good. The Tourist Mara boat that sails from Ulva Ferry to Staffa sometimes comes back in quite close to Ulva. And if the weather's good, you get some quite nice pictures. These are the basalt columns seen from the boat. And it's quite dramatic. And again, that's the ones that pictures that I showed you earlier, but this time seen from the boat. And there's just another view of it. And that's further west. The basalt columns in Ulva actually extend quite a way west for quite a distance, although they don't form the sort of continuous cliff. It's broken up, and there's lots of sea stacks and things. I mentioned Artun earlier. Artun's a great place to go and look at it. I mean, there's the famous leaf beds there, but the basalt columns are fantastic. They're really, really good. That's just a hammer for scale. And there's this famous sea stack called Bitaskarev, which means the point of the cormorant. You'll frequently see cormorants sitting on it. And there's that great cave in the rocks and the columns at Artun. It's tremendous coastal. The best time to visit Artun is when the tide is away out. Go right out in a low tide, because you'll see so much more. When the tide comes in, a lot of this gets covered. So if you're ever visiting it, make sure it's a low tide that you get. You'll see so much more. That's where the leaf beds are. That was one of my persons that were on a trip just having a look for them. Although the best place to find examples of the leaves aren't actually in the cliff itself, but in the gully down below, where there's lots of fallen blocks. There's quite a few bits to be seen down there. So across from Artun, you've got the wilderness, the fossil tree area. Now there's this thing that looks like a big daisy, a circular looking structure on the shore. And I reckon that is the cast of a tree. That circular bit in the middle is where a tree would have grown. And it's been completely engulfed in lava, and it's caused the columns to develop a radial pattern. And well, the tree is obviously long gone now, and it's left this hole. It's a really unusual looking feature. And you can see it well from the cliffs. That's described in one of those Williamson and Bell papers. They describe it in a bit of detail. And this is where the fossil tree is itself. That's the fossil tree is, the cast of the tree is here, and the remains of it have been covered with cement to preserve it at the bottom. So it's that's the famous McCulloch's fossil tree. And there's lots of columnar basalt all round about there, as you can see. That's me standing beside some. Now, I was talking about how you get these horizontal cracks, these horizontal joints, as well as the vertical ones, and it looks like a pile of nuts. And there's a nut standing beside these nuts. Hey, there we go, past the fossil tree. And again, you can see how there's all this collapsed stuff. It's a lot of this stuff, it's not particularly stable. So that's what that's there. And that layer underneath, that's an ash layer that you're seeing at the bottom of the picture. There it is again with great lumps of it, volcanic bombs. So when the ash was thrown out, there were solid lumps embedded in it as well. And then you can see the columns just at the very bottom of the picture. Karlis Arches is a must, although it's a fairly arduous, fairly lengthy trip to get to. This is the Karlis Arches area. That's Malcolm's Point. And that's the highest point. That's the Staffa lava formation extends all the way up there. It covers quite a height. And these are the famous arches. There's two of them. One of them's like a cave, and the other's like a sea stack with a hole through it. The hole's shaped like a keyhole. It's quite an interesting looking thing. That's the other side of the arches, showing the columns. And that's a close-up of the arch. It's cave-like. It's a big cave that goes right the way through. And that's the other one that's got the keyhole-shaped hole in the middle of it. It's just an eroded sea stack. And there's a little column sitting on the top there, like some sort of chimney. So that's the Karlis Arches, but I mean, they're not near Karlis, they're well away from it. And it's whether you go from the east or from the west, it's a fairly long walk. It's a full day you're talking about to get to there. And the same is true of the fossil tree. If you ever visit the fossil tree, it's a long hike. So east of Karlis, there's some good stuff, and this is a bit more accessible. There's these beautiful columns that you can look up into the underside of them. They're really quite neat. That's what they look like. Beautiful columns. And you've got this sea stack with a cave in it. And again, that's columnar basalt, it's an isolated sea stack. A bit that's been a little bit harder than the rest. It's resisted erosion. And there's a cave with a waterfall over the top of it in this formation as well. And if you get it just right, you'll get a rainbow in it. So it's beautiful scenery around there. It's a great place just to go for a walk. And it's not too difficult to get to either. It can be a bit boggy in places, but it's well worth a visit. I mentioned Glach Vor near Bloody Bay, and this is in the northeast of Mull, just north of Tobermory. It's near the fish farm there. And you've got these beautiful little columns. They're they're really quite nice, slightly curved. That's Glach Vor. It's one that you'll very seldom see it referred to, but it's fairly straightforward to get to as well. But yeah, nice little columns there as well. Just round from Alva Ferry, there's a point of land called Arsgeric, the Red Point, and there's some nice stuff there. That's the basalt columns at Alva Ferry. I showed this earlier from a slightly different angle, and that's what they look like. This is Arsgeric, and that's looking across to Benmore covered in snow. So that was quite a nice day, that. So the Arsgeric columns are very, very similar to the ones in Alva. It's just, I'm sure it's just a continuation of the same thing. And that's them from the bottom looking up into them. So it's fairly accessible as well. You can get to it from near the fish farm. There's a track goes down to it. And it's a climbing ground as well. There's a few climbing routes been put up on this. Although, mind you, having seen how some of these columns collapse, I don't know how wise that is, but anyway. There's a place near Ardmore Point called Boroshalovic, which is the point of the sorrel. Shalovic is Gaelic for sorrel, and the point of the sorrel. So it looks like this. That's looking over to Ardnamurchan. That's Ben Heant that you see over there. And there's these beautiful little columns. That's them again. And there's a fantastic dike called Botach Arsmore, the old man of Ardmore. And this is it here, seen end on. And when you look at it face on, you can see the columnar structure, but you'll notice that the columns are going across the way. They're not vertical, they're horizontal, because as I said earlier, the columns form at right angles to the cooling surface. And the cooling surface was obviously the vertical rock that this was intruded into, which has since been eroded away, leaving this thing standing up like a wall of rock. So it's a great place. It's quite awkward to get to. There's an awful lot of vegetation, like brambles and gorse and bracken, all sorts of horrors on the way. So east of Sgúr, there's a place called Porthnadroyan, the port of the brambles or the thorny bushes. And this is what it looks like. Now in the distance there, get the mouse, you'll see that's Malcolm's Point. That's where Karlis Arches is. So this is further west of, much further west of Karlis Arches. And this is probably the furthest west this columnar basalt goes on the south coast of Mull. And you can see it's got a distinctive columnar pattern to it. Very distinctive ruler there for scale. But there's some really interesting sedimentary rocks in amongst this. I mentioned the sedimentary layers in between the columns, between the lava flows. And you've got stuff like that. That is a piece of fossilized wood. That is actual wood in amongst the lava. So there's some quite interesting stuff like this. I was there with the VMSG field trip a couple of years ago, and that's where this picture came from that trip. And it was really interesting to see this. Finally, I mentioned the Laggan Peninsula because there's stuff there that looks like, I think it's columnar anyway. This is taken from John's boat, and we're looking over towards the shore, and it's got a slightly columnar look about it. It's maybe not that great until you zoom in a bit, and you can see this sort of stuff going on. So that definitely looks columnar to me. That's some sort of columnar basalt right way down that remote corner of Mull in south. It's much easier to get to by boat than it is by walking. The easiest way to walk to that would be from Lochbuie, but it'd be a long day out. So that's another place, but this isn't documented anywhere. So other places with columnar basalt. Well, there's Iceland. There's Samson's Ribs in Edinburgh, Holyrood Park. There's Columbia River in the United States. There's a thing called the Devil's Tower in the USA. And there's the Devil's Postpile. A lot of these formations seem to have some reference to the devil for some reason. There's the famous chain walk at Ely in Fife. And there's the Rock and Spindle at St Andrews in Fife. And there's Mars. So let's have a wee look. There's Iceland. I've shamelessly nicked these pictures from some Icelandic website, not given credit, so apologize for that. But Iceland is utterly spectacular. You don't just have basalt columns, you've got cracking waterfalls. You've also got some really nice glaciers and brilliant auroras. And you've also got volcanic eruptions going on. So it's a photographer's dream. And that's the Svartifoss waterfall. And the columns there are really spectacular. That looks almost a bit like something you might see in Mull. I always think that looks a bit Mull-like, that one. And this as well, that's in Iceland. Lots of fallen columns there. So wherever you go, columns seem to collapse. And there's this beautiful ravine, the colour of that water, and these fantastic columns. So yeah, Iceland's the place. This is Samson's Ribs in Edinburgh. I'm sure I'm straying onto Angus's territory here. This is in Holyrood Park, Arthur's Seat area. So yeah, these are really nice. I'm not sure, maybe Angus can confirm. I think this was deemed dangerous until recently. I think the road was cordoned off or something, but yeah, it's because of rockfall. But yeah, Samson's Ribs. This is the famous Columbia River basalts in America. This is a fairly extensive lava formation, this one. And it's beautiful, neat columns there. This is the Devil's Tower in Wyoming. Now, this is a bit different from the rest. I've seen various explanations given for what this is, and it might be what's called a stalk, the root of some sort of volcanic system. And everything else has been eroded away, leaving this. It's quite a spectacular thing because it stands up above a very flat landscape. And this is the other devil's thing, the Devil's Postpile, California. That looks really amazing, that does. You've got straight columns, you've got curved ones. Again, presumably reflecting changes in the topography of the landscape that the lava was erupted onto. And there's the famous chain walk at Ely in Fife. Now, I don't know how many of you are familiar with this, but we went there just this summer, and it's like a via ferrata in the cliff. And you walk along this using these chains for access. And there's some fantastic rock scenery. I mean, it's absolutely spectacular. And there are these great columns. Look at these. They're really excellent basalt columns. Now, these, I mean, most of the columns that you see, well, all the columns that you see in Mull are tertiary or Paleogene. This stuff's much older. This is Carboniferous. And there it is again. They're really, really nice. And the chain walk is something, if you're feeling fit and healthy, it's well worth doing. Pick a good day when the tide's out, and it's really good. And I mentioned the Rock and Spindle. This is, I remember first visiting this as an undergraduate, and I still find it impressive. It's this eroded stump of a volcano, a volcanic neck, as they get called. And you've got this sort of sticking up bit, and you've also got this bit with the radial columns. You know, they stick out like this. And it's probably some sort of pipe-like system that the columns have developed on. I'm not totally certain why it's like that, but yeah, it's a very distinctive thing, the rock and spindle. I mentioned Mars. Now, this is actually columnar basalt on Mars, or columnar rock of some sort anyway. And it tells you these are the first columnar joints positively identified on a planet other than Earth. Now, it's probably a bit hard to see there, but when we zoom in a bit, there you are. You can see that band stretching diagonally across. That's columnar. So columnar rocks on Mars, not just on Earth. It's pretty cool. So other columnar rocks, what is there? Well, there's the Lochba ring dike. It's got columnar stuff in it. There's the Craigignele, the Kilt rock and Skye. There's a sill at a place called Tavul in Mull, which isn't far from a fossil tree. And there are various dikes. I mean, loads of them showed. I showed you one earlier, that thing at Ardmore. And there's a little island called Staffa west of Iona, where there's some beautiful columnar structure developed. And you also get columnar sandstone, which is a real oddball. So here's a map taken from the survey of from the memoir of the Geological Survey, showing the extent of the Lochba ring dike. Now, although it forms this nice ring-like feature, the place where it's best seen is between Bynangoter and Lochba. That's definitely the bit where it's best seen, and particularly up on the hill called Benagrake, which we'll see in just a sec. This is on Benagrake, looking down the ring dike towards Lochba. And that's the sea, it's Lochna Keel over in the very top left there. You see, it's very light coloured rock. It's a granitic rock rather than a basaltic one. And here are some columns in it. This is taken from a paper written by Colin McFadden of SNH, and it shows columns in the Lochba ring dike. Now, the reference has actually got the grid reference to this. And I went there trying to find this, and I really struggled to find anything that looked remotely like that. But higher up on the ring dike, you've got this. This is much higher up near the top of it. You've got a very distinct columnar structure. It's really obvious. I mentioned Craigignele, or the Kilt rock in Skye. Now, this isn't a lava flow. This is a sill, a big dolerite sill of tertiary age cutting Jurassic rocks. So what you got there is the Jurassic rocks underneath, those lighter coloured things. And you've got this great sill cutting across it. There's also another sill much lower down, closer to the sea, that you can see it's the same colour, that sort of brown colour. And the brown weathering is caused by the iron minerals weathering out of the basalt. So that's the Kilt rock. It looks like the folds of a kilt, pleats. Yeah, it's a good one, that. I mentioned the sill at Tavul. Well, this is it here. You can see the columns, really distinct. And that's just some close-up of it, just to show you the top surface. And that picture on the top right there, that's my boot. You can see in the very bottom left. And you know, the column's quite well developed. The Tavul sill is one of these sills that's marked on the map as containing sapphire, for anyone that's interested. So it's a sapphire-bearing sill. I showed you a dike earlier that had a columnar structure. This is one that's probably a bit easier to get to. It's at Calgary. And someone once described this as looking like Staffa on its side. You can see the columns are going across the way. You know, they're not vertical, they're going across the way. Again, as I mentioned before, the columns develop at right angles to the cooling surface. So that's why that looks like that. And the little island west of Iona called Staffa, this is what it looks like. A couple of seabirds up there keeping watch on things. It's a columnar sill by the looks of things. Very distinct columnar structure to it. And finally, a real oddity. This is the columnar sandstone in Butte. It's near the south end at Kilhatton Bay. And as I say, it's very unusual. That's what it looks like. Now, if you were to see that from, you know, without looking at it in close up, you'd say, oh, that's basalt or dolerite. It's a bit like somebody had seen Staffa. Here's another picture of it. But it's not, that is actual sandstone. And the reasons for it, I mean, I think there's a paper being published on this, but they reckon that it's because the sandstone has been affected by an igneous intrusion nearby. But what makes me wonder, and I haven't a clue really, to be honest, why do you not get this elsewhere? If sandstone can be so affected by igneous intrusions that it develops this columnar structure. You know, there are lots of places in the Hebrides where you've got igneous intrusions cutting across what do you call it, sandstones. But this is extremely rare, this sort of thing. So I think there must be some special set of conditions, possibly due to fluid flow through the sandstone, to actually cause this to happen. Very, very unusual. So to finish off with, we shall have cakes at the columns. When I do my field trips, my little geology walks, if there's columns involved, there's always cakes. There's nothing better than sitting with a couple of Mr. Kipling's French fancies with a cup of coffee, sitting beside some basalt columns and just take it all in and absorb the beauty, the nature's sculpture that is basalt columns, because they're truly magnificent, they're glorious things. So sit down and enjoy. Thank you. That's our turn, by the way.